is in motion, then definitely we'll say that as like as it starts moving. So let me put velocity here. So as it starts moving, what happened to position vector? The position vector is going to change that one. But we know according to the de Broglie matter waves, anything the matter will be in dual nature. Means now if it is at rest, what is the wavelength? Wavelength will become infinity. That's all, lambda equal to h by mv. As the particle is at rest, then sir, any waves also, as the waves are there but of infinite wavelength. You should not say no matter wave. This is something very important. Always a matter will have a dual nature. They will coexist, and depend upon the situation, that particular thing what will come into existence. Don't think that if body at rest, no matter waves. Body at rest, the matter will have infinite wavelength. I think able to make it out here. Means now you are able to see that particular the object is at rest, as you are able to define that position. If it is in motion, if it's in motion, let's take that one. So is there any matter waves associated S? So what is the formula? Lambda equal to h by mv. Then so what is this lambda? Lambda is something associated with the matter waves, no? And what is particle? Particle is something we define it by its position only. Yes, particle is there. So the moment you say the particle is present, the ball is present, very first thing what we say, where it is, the position will come into picture. Then if I go for matter waves, then very first thing is what, like what is the wavelength? What is the wavelength? And this particular matter waves wavelength depends on what? Depends upon the momentum. So therefore, for every object what will happen, there will be a waves associated with it. Means anything. So here I should also show the wave. Which one you are noticing now? The present, our human eyes, everything is what we are able to notice the particle nature of the matter. We are unable to notice the wave nature of the matter here. Whether it's rest or in motion, the matter what happen will have both the things, both the entities. You call better entities here. Then what Heisenberg he noticed is like, can we realize both at a time? And can we measure both the wave nature and particle nature simultaneously and perfectly? Are you trying to get my question? Can we define position of particle? Yes, very easily. Can you define the wave nature of the particle simultaneously, both particle and wave nature? Is telling there is some uncertainty. Uncertainty why it will come. If you try to measure the exact position, what happens by the time the particle will undergo displacement. So here, after some time, what happens? The particle will be here. So initially, this was at position 1, and you want to measure its like a particle nature. So for that you need position, no? And since it is moving, so the moment you say that as the particle 1 is here, okay, let me go and measure what when the particle will change the location. So what you are unable to measure the location of particle, no? Why that is? Because of momentum. Similarly, you want to measure the velocity. To measure velocity, what you need? The displacement. So definitely, if you try to measure the velocity, then what happen again? You'll do some error in the displacement. There's uncertainty is there. So for that purpose, what will happen? The uncertainty in this is greater than or equal to h by 4 pi. This is some constant is telling. What is delta? This delta is uncertainty. Yeah? Don't say this one. This delta is x is the position, p is the momentum, delta is uncertainty. Don't say delta x is uncertainty. No, delta is uncertainty there. And if I measure and if I take the product of that uncertainty, it is something like it cannot be less than h by 4 pi. It should be greater than equal to 4 pi here. Means if you try to measure delta x, if you measure try to delta x, there'll be uncertainty will arise in the momentum. If you try to measure the momentum, means if delta x is measured exactly what happened, then the lot of uncertainty to come in momentum. If you measure the momentum exactly, then what happened? Lot of what do you mean by uncertainty? Sir, you are saying uncertain. What is that? some error better in simplified language. So shall I put like this? If one value is known, if one value becomes known, the other becomes unknowable. If you measure exactly delta x, then what will happen? You cannot measure momentum. That's what he mean to say. If you measure exactly delta x, then what happen? You cannot measure momentum. So definitely what happen? We have to make a compromise here. We have to make a compromise. So this called like a conjugate variables. Like this, the displacement, this one. Sir, still we are not understanding anything. What you are saying, this we are not able to understand. We are not able to understand. So let's get into the little bit some quantum ideas.